All right, hello everyone. This presentation is titled How AT&T Saves Thousands of DBA Hours Meeting Password Security Compliance. What we're going to go over today is who we are, monitoring databases at AT&T, meeting password security compliance, our solution, and the next steps. I'm going to start introductions. My name is Glenn Cronick. I work for AT&T. I've got over 35 years of IT experience with Bell South Mobility, Singular Wireless, and AT&T. I've been an Oracle DBA for a lot of those years. And in the last, I'd say 8 to 10 years, I've been working with solely Oracle Enterprise Manager, and those versions 10G through 13C. My partner in all this is Olga. Olga, you want to introduce yourself?
So been in IT for 27 years and starting with just software development and then jumping to database management. Been working in production database support with Oracle version 6 and up. I guess majority of my career is at AT&T at different companies that AT&T creating and acquiring. The OEM was part of all those roles since the OEM's been released from version 8 through 13C now. That's what we have, 13.4. That's about it about me, and back to Glenn.
All right, thank you, Olga. We're going to be talking about 13.4 mostly in this presentation, but we do talk about the other versions and what we're doing as it relates to this presentation. We talk about a little about AT&T. Of course, it's one of the world's largest telecommunication providers. We're delivering the highest levels of service is as important as well as the privacy and security of our customers' information. Our DBA team at AT&T is responsible for supporting high service levels, which we do by monitoring and managing over 11,000 Oracle databases that host our mission-critical applications. We use Oracle Enterprise Manager to monitor our large fleet of Oracle databases. Along with managing performance and availability, a critical responsibility is to comply with AT&T's security requirements. For example, one security requirement is to change the Enterprise Manager monitoring account password, which for purposes of this is assumed to be DBA, and we have to change this on a regular basis. With around 11,000 databases, asking the DBAs to change the password in the database and within Enterprise Manager is very demanding and time-consuming. On average, we estimate it takes 15 minutes to change the database password and to change the password in EM, especially for these databases configured with primary and standby databases. Oracle Enterprise Manager provides a job named Change the Password for the database monitoring user that can be used to change the monitoring user's password for database instances and cluster database targets in EM. We were challenged with how we could take advantage of this job type to change the password on a regular basis. The straightforward approach would have been to run a job against a group of databases. However, this does not work for us because the day on which the password needed to be changed and hence run the job varied across different databases. Another approach would have been to consider using the job as a corrective action, which we could have triggered when the DBA account would soon expire, using the out-of-box metric account expiry in hours. However, we assign a specific profile to DBA account that does not expire the password. We do this to prevent any DBA account from becoming locked and thus not being able to be monitored. Due to this profile used by DBA, we could not use the database metric account expiry in hours to indicate how soon the password would be expiring. Instead, we create a metric extension while still using the job as a corrective action. And for purposes of this presentation, AT&T requires that we change our passwords on a regular basis. We assume the account that's going to be used to monitor the database targets is the DBS and a B account. The challenges we were up against, of course, is the man hours it would take to do this. 15 minutes per database would end up taking, I don't know, close to 71 weeks of DBA time across 11,000, in this case, 11,400 databases, which would entail one DBA spending 40 hours a week, 71 working weeks to make this change. So the solution we came up with was to create a metric extension. We use sys.users dollar and queried against the p time column to check how long ago the DBS and password had been changed. The metric extension, or ME, returns the number of days left before which the password needs to be changed. We designed the ME to collect and evaluate the threshold every 24 hours. And then we had to create a metric extension for both the database instance and the cluster database. One thing to note here is, we couldn't use the DBA users view and the expiry date column because the DBS and the P account uses a profile that doesn't expire the password. Good news is going forward in 12C, we don't have to rely on the users dollar table for this. 12C, we can now use a sys. double quotes _ base _ user view and the expiry date. And in 19C, we can go back to using the DBA users and looking at using the column password change date. So the alert would trigger when there's less than n days before required password change. As you can see here in our example, we have when the number is less than 30. In this case, 30 days. This metric extension is just going to use the default monitoring credentials. So the corrective action that it would take, we're showing here on this page just the targets that have this particular corrective action applied. So we see that. All right, so here's the corrective action. We're using, this example is on the database instance. I'll show you how we fill out the rest of these tabs. We're going to auto-generate the password. The reason we want to do that is we don't want anyone to know the password. We don't want it to be used by anyone. So that was a key for AT&T. There's no credentials needed for this corrective action. The credentials taken from the target and the preferred credentials of EM user applying the template. All right, so we have the metric extension created, putting it together in the monitoring template. So here is our example of the template we're creating and what number of days we want to fire the corrective action. As you can see in our example here, we're using 96 days. We're going to edit that, and then we assign the actual corrective action. And as you can see in the square, the corrective action called change password DBS and P database instance is going to be called. And then, of course, we're going to take this monitoring template and apply it to all our database instance targets. All right. We're also, for new database targets, we're going to update our existing default monitoring template that we use here at AT&T. We have a default monitoring template for all our target types. And that way, any new targets that come along, this metric extension will be included. As an example here, we have DB1 metric extension triggers an alert when the password needs changing in less than 30 days. In our case, it's really 96 days as we showed in that particular template. Corrective action runs, which does the following. He first puts the database instance into a blackout. He then auto-generates the new password and updates it in the database and in EM's named credentials, along with the agent's monitoring credentials. He stops the blackout, and the alert automatically clears. When we implemented this solution, of course, it didn't support DBSNP configured with sysdba role or in a standby environment. We plan to use the enhanced change password for database monitoring user job, which now supports standby databases in these next set of releases, EM 13.5.06 and 13.4.0.18. For references on this, you can please check out our blog, More Secure and Efficient Changing DBSM Password Using Automation. Also, you may check out Oracle's documentation, Automate Monitoring User Password Management, and the automatically synchronized password files in Oracle Data Guard configurations. You know, with this new enhancement, this is how it would work. With your primary and your standby database, the job does this. He puts the primary and the standby database in a blackout. He then auto-generates the new password and updates the password in the primary database. He updates EM name credentials and the agent's monitoring credentials. And in parallel, the password in the standby is updated using the Data Guard automatic password synchronization feature. As you can see below, this was introduced in 12.2, except for far sync or snapshot standby databases, which here at AT&T we don't have. So in summary, automating our password change solution saves us thousands of hours of DBA time. This frees up a DBA from having to spend so much time doing this. It avoids human errors. If the DBA was having to do this manually, he could easily update the credentials in one place and forget to do it, you know, and let's just say at the database level, and then forget to do it in EM. This allows the DBA now to focus on more strategic work for our customers and enables us to meet our security compliance requirements. Thank you all, and that ends the session. We'll open it up for questions.